Hello, hello. This is narrator Mr. Newlove. I'm here again. If you have not subscribed the channel, you can subscribe. Today I want us to look at counting principle. Um, so let's first look at the first rule. Counting principle. Okay. Now the first rule says m times n times k times any letter or any variable. When you have a question like this, there are 4 shirts, 6 skirts, and 8 pair of shoes in a wardrobe. How many combinations of the outfit can be made? That is where you use this one. So a question like this, how do we use that one? This m is the 4 times this n is the 6 times this k is the 8. You just multiply them to get this value. Okay, let's do another example. Example 1, example 2. Our example 2 is going to be in a wardrobe. There are 20 shirts, 14 shoes, and the last one, it can be any trousers or whatever, skirt, shorts, how many shorts? 12. How many how many? How many combinations of outfits can be made? Wow. Similar to that one, eh? I know you know the answers now. So how is it going to be? Our m is 20 times our n is 14 times our 12, whatever number. So this is what it's going to give us. Okay, let's get our calculator. Good. During your trials, when you are solving questions like this, don't rush. Don't think it's easy so you rush. Take your time, get it correct. Alright, every mark counts. So 20 times 14 times 12 gives us 3,300. 3,360. So easy, nah? Now we are going to look at the second rule. And what is that second rule? The second rule is actually the factorial method, where you use the factorial. Alright, so our second rule, what is our second rule? Factorial notation. So let's look at a question. Here there are 8 chairs and 8 children. How many ways can the 8 children be seated in a chair? When you have a question like that, 8 chairs and 8. So since we have 8 chairs, it means we have 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Alright, and these 8 spaces are supposed to be filled by children. So if you check the first space, all the 8 children can sit on it. Not all of them, but there are 8 ways for these 8 children to sit on it. The first child can sit, or the second child, or the third child, or the fourth child, or the fifth child, etc. So there are 8 ways that the first seat will be seated by these 8 children. So all in probability means plus. So the first child can sit on it, or the second child can sit on it, or the third child can sit on it, or the fourth. So there are 8 ways. Now the first seat has been taken. The second seat, how many ways? The first child can sit on it, or the second. Since the first seat has been taken, how many children are left? 8. Sorry, 7. 7 children are left. So 7 ways that the second seat can be occupied. It can be the first child, or the second child, or the third, or the fourth, etc. So it moves like that. 2 spaces has been occupied now. It's left the third space. It means 2 children or 2 learners has been used. 2 children have been used. Or so how many children are left? 6. Then it goes like that. Alright, up to the last one. Instead of writing all this long strip, you just write 8 factorial. So 8 factorial, you can have it on your calculator like this. 8 and the factorial gives us this. Okay, now let's look at another example for this. Ways can the first 4 places be occupied? 12 children in a race. There are 12, but we need from first to fourth, only the first to fourth. How are you going to solve this one? Since we need only 4 people, it means there are 4 spaces. So the first space can be occupied by the 12, any of the 12 children. It can be the first child, second, third, or fourth, etc. Now the first space has been used. The second space is left with 11, because the the first space has been used, so the rest of the spaces, or the second space, is going to remain with 11 because 1% is being used here. How? Because 11, to remain with 11 ways to fill this side. Then, since this side is used, it means two spaces has been used. The next space can be filled with 10, followed by a 9. You cannot call this factorial because it doesn't continue like this one. It doesn't continue like the first one to 1. Alright, it ends here up to 9. And this one, what is it going to give us? It's going to give us 7,880. There's another way of solving this one. It's going to be 12 factorial over 12 minus 4 factorial. So this is also another way of solving the same question. Alright, the same question. You can either do it this way or that way. And this way, how? 4 spaces are supposed to be filled by children. The first space can be filled by any of the 12 children. It can be child 1 or child 2, and I said all in probability and counting principle is plus. So it can be child 1 or child 2 or child 3. The second space can be filled with 11 learners. Why? Because the first space is occupied by 1 child. So it will remain with 11 children. Then the third space is also like that. 2 spaces has been used, the first and the second child. So it's going to remain with 10 children. So this space can be filled by any of the 10 children. And it goes like that up to 9. Then the second one is a formula work. So the 12 learners, the total number of children that are supposed to go for the race, you write it here, factorial over that total minus the number of learners or the number of children that are supposed to be taken. Remember, there are 4 children that are supposed to be taken for the next round. Okay. Now, let's look at rule 4. Rule 4 is also nice. Consider the word new love. Consider the word new love. How many different ways can the word new love be arranged? How many different ways? Okay, let's see the ways that we can use to arrange the same word, new love. That is rule 4. Now, this rule, you first consider the total number of words that we have. How many? 1, 2, 3, 4, 5, 6, 7. 7 letters. 7 letters. So it's going to be 7 factorial over the number of letters that repeat. How many letters repeat here? 2. Only 1 letter repeat, that is E. And E repeats how many times? 2. 1, 2. Alright. So here, you see that E repeats 2 times. So you count 1, 2. So that is 2 factorial. Okay, we'll look at another one where we make use of the P, because the formula is what? N factorial over a different value, factorial times a different letter, factorial. Okay, so let's see how we press the factorial on the calculator. We've done it before, we are doing it again. So this one is going to be 7 factorial over 2 factorial, and this gives us this one. Okay, now let's look at another example. Consider the word needed. How many ways can the word needed be arranged? The word needed, let's see how it can be arranged. But before that, let me split this into 2. How many ways can the word needed be arranged? So this is what we are looking at, alright? And I'm answering it down here. Okay, so the first thing, we use the same thing, the same formula. Let's count the letters. 1, 2, 3, 4, 5, 6. There are 6 letters. So it's going to be 6 factorial. Then let's look at E. How many letters repeat here? 2 letters, E and D. How many E's do we have? 1, 2, 3. So that is this M. 3 factorial. Times how many D's do we have here? 1, 2. That is N. 2 factorial. So when we press this on the calculator, let me see. You don't have to, if like you already have the division or the fraction sign on the calculator, you don't have to delete and start all over in exams. Just type your 3 here times 2 factorial. Then move the cursor to the numerator, change it to 6. Equal, you have your 60. So you don't have to delete everything. No, it's a waste of time. Alright, but when you are doing this, be careful, take your time so that you don't make mistakes. Okay, let's look at another one. The same, we are still on the same rule. Let me put the question at the top here. Consider the word come. You are required to form different 4 letters word arrangements between the letters of the word come. Okay, so this, let's see the question. It says how many, so from here, consider the word come. You are required to form different 4 letter word arrangement using the letters of the word come. How many possible word arrangements can be made? Wow, let's see how we can answer this question. The letters may be repeated. That's the first question. So it means if the letters can be repeated, if you use it in the first space, you can use it in the second space, and like that. You can use it in the first space, second space, third space, fourth space. Alright, so let's count the letters. 1, 2, 3, 4. So the first space is 4 times 4 times 4 times 4. How? The letters from come, if you count it, is 1, 2, 3, 4. So the first space can take any of the letters, so which is 4. It can take C or O or M or E. So it's 4. And the second space, if you use C, you can still use C in the second space. So the second space can also take C or O or M or E. The third space can also take any of them, C or O or M or E, because the question says the letters may be repeated. You can repeat the letters. If you use it in the first space, you can use it in the second. third. So the fourth is also going to be like that. So here, what is going to be our answer? 4 to the power 4. Alright, and 4 to the power 4, if you press on the calculator, what are we going to have? 4 squared. So we have 4 to the power 4. Then we have our 4. 4 to the power 4 is going to give us 256. Okay, now we are continuing with the question. The same question. How many letter arrangements can be made? So this word come, we are considering the word come. How many possible word arrangement can be made if this word come, if the letters may not be repeated? What does it mean? If you use it in the first space, you can't use it in the second space. The letters cannot be repeated. So you can use it in the first space, you can't use it in the second space. So here, what are we going to have? The first space can take any of the 4. The second space will take 3. Why? One letter has been used here. The third space can take 2. Why? 2 letters has been used in the first and the second space. Then the last space will only take 1 because 3 letters has been used in the first, second, and third. So it will remain with only 1 letter, which is 1. So here, this is 4 factorial. You've seen the difference between this and this. This is 4 factorial. And 4 factorial, let's press on our calculator. We are going to have what? 4 factorial. It gives us this one, 24. Okay. Now, we are moving on to the next question. Let me bring the next question at the top here. Then I use the down for answering the questions. Okay, the question says, the security system requires a user to choose a security code. The code consists of 5 digits. How many different code can be made if the system allows repetition of digits? Wow, what a question. How are we going to answer this? Okay, now I'm going to make code from 10 digit numbers. What are the digit numbers? It starts from 0 to 9. They are 10. So it means the code must consist of 5 digits. So the code must consist of 5 digits. Alright, it can be 1, 2, 3, 4, 5, etc. But it must be 5 digits. So it means we have 5 spaces, 1, 2, 3, 4, 5. Alright, 5. So here, the first space can take any of the 10 digits. So it can be 1 or 2, it can be 0, 3, etc. Then the second space can also take any of the 10 digits. Why? The question is, the system allows repetition of digits. So if you use 1 here, you can still use 1 here. So it can take any of the 10 digits. The question is, somebody may ask, what is the digits that Mr. Newlove is talking about? We have 10 digits. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are 10 digits. Okay. The system allows repetition of digits. So, and we are supposed to create 5 digit code. 5 digit code. What are the digit codes? Let's use a card. When you go to ATM, you are supposed to press your password, and the password for card mainly is 4 digits. Maybe 2, 3, 5, 8, 2, 6, 7. Alright, so those things are the digits that we are talking about. The password. Here the password is not 4, it's 5. So it means we need 5 spaces. 1, 2, 3, 4, 5. The first space can take any of this one from 0 to 10. It can be this or this or this or this or this or that up to 10. Then the second space and the second space and in probability and counting principle is times. The second space can also take any of the 10 digits. It can be the first or the second or the third or fourth, etc. Why? The question says the system allows repetition of digits. I'm just repeating what I've already said now. Okay, so it's going to be like that. And we are going to have 10 to the power 5. Let's move on to the next question. The system does not allow repetition of digits. It does not. It means if you use it in the first space, you can't use it in the second space. So what do you think this one is going to be? The factorial. Alright. Now the first space is going to be this. Second space is not going to be 10, it's going to be 9 because the first space has been used, or one digit has been used in the first space. So the second space is going to be 9. The third space is going to be what? 8. Why? Because 2 digits has been used in these 2 spaces, and it goes like that. Okay. Or we can use this formula. If we use this formula, what are we going to have? If we use that formula, we are going to have this. That is good. The next thing that we are going to do is question 3. A grade 10 learner has an accounting, physical sciences, Zulu and mathematics textbooks. How many ways? Let me bring it here. How many ways can they be arranged on the same shelf? How many ways can they be arranged on the same shelf? So the first, we have 5. It's going to be 5. Why? Because we have how many books here? 1, 2, 3, 4. Accounting, physical sciences, Zulu, mathematics is supposed to be 5 books. So let me use geography. Okay, so we have 1, 2 physical sciences is 1. So 1, 2, 3, 4, 5. So 5 books. And the question is saying how many ways? How many ways? how many ways can they be arranged on the shelf? So it means on the shelf we have 5 books. Alright, because there are 5 books. So the first space can take 5. The second space can take 4 because one book has been used. The third space can take 3, 2, and 1, which is 5 factorial. Okay, now the next question is this one. In how many ways can the letters of the word duck be arranged? Repetition of letters is not permitted. Let's answer that one. Okay, so here we are not repeating the letters. Duck. Duck is how many? Let's count. 1, 2, 3, 4. So the first space can take this, second, third, and fourth. So the first space can take any of the 4 letters. The second space is going to take 3. Why? Because the first space has taken 1 letter. So how many letters are left? 3. The third space is going to take 2. Why? Because the first and the second spaces has taken 2 letters. How many letters are left? There are 4 letters, so 2. And the last space is going to take 1. Why? The first, second, and the third, they have taken 3 letters. So how many letters are left? 1. Why? Because there are 4 letters. Okay. Then let's look at this one. Night. Consider the letter word night. How many word arrangements can be made with this letter? How many word arrangements can be made with this letter? Letters are not repeated. It means if you use it in the first space, you can't use it in the second space. Letters are not repeated. You can't repeat it. So this factorial comes in. So how many letters? 1, 2, 3, 4, 5, 6. 6 letters. So we have 6 letters. Okay. Now 6 letters. We have 6 spaces to fill. Alright. Because all the letters must occupy 1 space. So we have 6 spaces. Because there are 6 letters. So the first space, any of these 6 letters can fill this here. It can be K or N. Or in probability means what? Plus. So it can be K or N or I or J or H or T. Alright. So how many K's do we have there? 1. How many N? Or means what? Plus. So plus. How many N? 1. Plus 1. Plus 1. Plus 1. Plus 1. So all of them is going to give you what? 6. 1, 2, 3, 4, 5, 6. So in exams you just count. So this is going to be 6. And the second space, and in probability and counting principle, is times. So and the second space. Now the second space, how do we get a second space? The first space has already taken 1 letter from here. It has taken 1 letter from here. So how many letters are left? 5. And the third space. The third space has taken 2 letters from here. 2 letters from here. So how many letters are left? 4. and it goes on like that. So this one is what? 6 factorial. Let's press our 6 factorial on our calculator. Don't delete. If you already have it, you delete only the 4. Put whatever you want to put there. We have 720. Alright. When you are working, be fast and accurate. There are some questions you need to be careful and take your time to do. There are some questions much time there. Look at the marks. Alright, look at the marks and attend to the question according to the marks there. If the marks is 2, it means you are not supposed to waste much time there. Like this one is 2 marks, so you don't have to waste much time there. Okay, how many word arrangement can be made with this word if the word starts with K and ends with T? Let me get a question at the top. Which word are we talking about? Night. Let me copy and put it below so that I use it to explain. Okay, now here our question number 2 is how many word arrangement can be made with this word if the word starts with K and ends with T? Okay, which word are we talking about here? We are talking about night. Alright, we are talking about night. This is the word we are looking at. Okay, how are we going to answer this question? The question says it starts with K and ends with T. How many letters are used? 2. Okay, let me start again. It starts with what? K and ends with what? T. But night is how many letters? 1, 2, 3, 4, 5, 6. So it means we have 6 spaces. 1, 2, 3, 4, 5, 6. But the first space is occupied by K. The second space occupied by what? T. Because the question says if the word starts with K and ends with what? T. So how many letters are used? 2 letters. So it's going to remain with 4, 3, 2, and 1. It's going to remain with 4 letters. So this space will occupy by any of the 4 letters left. Now this space is occupied. So this is also going to be occupied by any of the 3 letters left because one space is being used. Another space is used. Then 2 and 1. When you have this, it's going to be 4 factorial. Why? Because this is definitely going to be 1. There's only one K, so it's going to be 1. And this is also going to be what? T. Alright. Okay. Then, if you press this on the calculator, we are going to have our 4 factorial. So 4 factorial is going to be 24. Now, let's look at our next question. In how many ways can 4 boys and 3 girls seated in a row? Seated in a row. How many ways can this one be seated in a row? Let's check how we can answer this one. Now, 4 boys and 3 girls seated in a row. So it means we need 4 spaces for the boys and 3 spaces for the girls. So 4 plus 3 in total. What are we going to have? 7. So we have 7 spaces which is going to be 7 factorial. Remember the factorial rule. The first space we take 7, second space 6, third space, what's the third space? First space is 7, second space 6, third space, I hope you are saying it, 5, like that. Alright, that is the factorial. So it's going to end at where 1. So you have 7 times 6 times 5 times my 5 times 5 times 4 times 3 times 2 times 1. And this one is going to give us what? 7 factorial. Okay, let's move on. And if you press this on the calculator, you are going to get 5040. Our next question, in a row, if a boy and his girlfriend must sit together, a boy and his girlfriend, so it means a boy and his girlfriend must be together. So how many boys do we have? 4. Boy, 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 boy. How many girls? Girl, girl, girl. There are 3. But a boy and his girlfriend must sit together and have their own chat. Alright, so here we are going to put a boy and a girl as a block 1. So you see that I have a boy and a girl colored, they are 1 block, so I'll count them as 1. So in all, we are no more going to have 7 spaces again, like this 1, 2, 3, 4, 5, 6, 7. No, a boy and a girl must sit together, so we count them as 1. So we are going to have how many spaces? 1, 2, 3, 4, 5, 6. That's a 6 factorial. And n means times. This boy and a girl, with this boy and a girlfriend, can swap. That means a girl may come first and a boy may come second, or a boy may come first or a girl may come second. Is that okay? So if they swap, it's going to be what? 2 factorial. That's 2 factorial. Are we together? Let me repeat. A boy may come first and a girl may come second. Or in probability is what? Plus. Or a girl may come first and a boy may come second. Alright, so that is what? 2 factorial. Is that okay? Okay. Now, our next question. In how many ways can they sit in a row if the boy and the girlfriend are to sit together? In how many ways can they sit in a row if a boy and his girlfriend are to sit together? Wow. Let's see. A boy and his girlfriend must sit together. How many ways can they sit in a row if the boys and the girls are to sit together? The boys and the girls must be together. Boy, boy, boy. Girl, girl, girl. Alright. Not a boy and a girlfriend anymore. Now it's a boy, boy, boy. Girl, girl, girl. So they must sit together. So we see that we have the boys placed together. They are all sitting together, and the girls are also sitting together. So we count this one as a block 1. This one also as a block 1. So 1, 2, 2 factorial. Why? We have only these 2, 1, 2. So the first space can be any of the boys. Alright. If one space is used, the other one is going to remain with 1. So it's going to be 2 factorial. And these boys, they are 4. 1, 2, 3, 4. So that's going to be 4 factorial. So the first space can take any of these 4 boys. The second space can take 3 of them because one has been used. The third space can take 3. So 3, 2 is going to take 2 of them. Then the last one, which is going to be 1. So 4 factorial. And this one, these girls can also swap around like the boys. So it's going to be what's 3? 1, 2, 3. 3 factorial. The first can take 3, this 2, and this 1. Alright. So that is 3 factorial. And the trick is if you have 1, 2, 3, 3 factorial. 1, 2, 3, 4, 4 factorial. We have that one. Okay. Let's look at the next one. In how many ways can they sit in a row if the girls are to sit together? The girls are supposed to sit together. Let me bring it here. So it means the boys may sit together or they may not sit together. But the fact is, the girls must sit together, whether they like it or not. So here, what do we do? How many ways can they sit in a row if the girls are supposed to sit together? Girls are supposed to sit together. For the boys, they can sit together or they may not sit together. So I decided to put 1 boy here and 3 girls together and 3 boys in front. The girls may be in front like that. So I'm counting the 3 girls that are sitting together as 1. The boys, they don't care. They can sit together or they may not sit together. So this is 1 block. So we count 1, 1, 2, 3, 4, 5. 5 factorial. And these girls, they can swap around. Alright, so how many? 1, 2, 3. 3 factorial. Then we move on. It's going to give you 720. Let's just press this on the calculator, which is easy. What do? I already have my factorial there. I don't have to delete. I only have to press the times, then my 3 factorial. 720. Wow. Okay, let's see what we are going to do next. In how many ways can they sit in a row if the boys and girls are to alternate? Alternate, what does it mean? Boy, girl, boy, girl, boy, girl, like that. So here, what are we going to have to alternate? Let me put a question at the top. Alternate, it means boy, girl, boy, girl. So here we are going to have boy, girl, like that. The boys are many, so you must start with it. The boys are more than the girls, so we start with it. Boy, girl, boy, girl, boy, girl, boy. So since they are alternating, you count them as a block. So it's 1, this one. And if you check, the boys can swap around. This boy can come here first and second, like that. So how many? 1, 2, 3, 4. 4 factorial. And the girls can also swap around. This girl can come first, this can come second, like that. How many? 1, 2, 3. 3 factorial. Okay, that is good. Let's move on to the next question. Our next question is, whoa, technology. I know you can do this one. I know you can do this. Okay, how many word arrangements can be made with this word if the repeated letters are treated as different? Which letters are we talking about? Technology, né? So let me just copy this technology and put it here. We need technology in our life. Without technology, like, you will not see me here teaching you. Alright, so technology is good. Okay, now the question is, how many word arrangements? I only need this. How many word arrangements can be made with this word if the repeated letters are treated as different. The repeated letters are treated as different. Let's look at the repeated letters of technology. Which letter is repeating? O, O is repeated. But they are saying that we should treat them as different. So even though this is O and this is also O, they are not the same. We are treating them different. They are different things altogether. Alright. So with that one, it's going to be 10 factorial. How? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factorial. I've already explained factorial, so I'm not repeating again. Alright. The first space, we have 10 spaces. The first space can take 10, 9, 8, like that. So that's 10 factorial. If you press this on the calculator, you are going to get this one nicely. And I know now you know how to press that on the calculator. If you still having problem, you can message me. Okay, how many word arrangements can be made with this word if the repeated letters are treated as identical? Treated as identical. How many word arrangements can be made if this word? How many word arrangements can be made with this word if the repeated letters are treated as identical? That is the way. Okay, so you treat them as identical. You treat them the same. Identical twins. They look alike. Okay, so here, if you treat them identical, you see that if you don't treat them as identical, if you treat them differently, it's only 10 factorial, which we have already done that one. But if you treat them as identical, the same, we are going to divide it by the letters that are repeating. So this letters O is repeating how many times? 1, 2, so it's 2 factorial. And if you simplify, you get that one. Okay, next question. Our next question is, how many word arrangements can be made with this letter if the word starts and ends with the same letter O? Starts and ends with the same letter O. Wow. So it means it's supposed to start with O and end with O. So this one, it means we have 2 O's there, remember. Technology. So we have O here, and it's also going to end with O. 2 letters has been used. How many letters were we having? 10. So if 2 letters are used, we have 8. So it's going to be 7 like that. So it's going to be 8 factorial. Because it's going to be only one O, only one O. It's fixed. It can take only O. Only O. It's fixed there. Okay, so here we are having 8 factorial. Then the next question, how many word arrangements can be made with this word if the word starts with the letter O? It must be the word starts with letter O. This is my O. It starts with letter O. How do we solve this? I mean, the first space must occupy O. How many letters are left? 9. Alright. The first space it must take only one O. It's fixed. So the first space is a block. It's like a block. Whether you like it, it must occupy letter O. It's a block 1. So you pick only one O. How many letters are left? 9. So it's going to be 9 factorial. Okay, so that's 9 factorial. 9 times 8, 7, etc. Then we have our question. The next question, how many word arrangement can be made with this word if the word ends with N. It ends with N. How do we do that? We're going to end with N. How many letters? Similar to the O. How many letters are left? 8. Okay. Then we are going to say bye-bye. Thank you for watching. May God bless you and keep you. Bye.